In this video, we're rationalizing denominators. We need our denominators to be rational, meaning not having a radical in them. And we make our denominators rational by renaming the fraction. This is an example of the identity property of multiplication. And we talked about that in an earlier video, how using a form of 1, which is what the identity is, the multiplicative identity, will be very useful for many things that we do in advanced algebra. So, rationalizing denominators. So here goes. We've got 15 over the square root of 6. Remember, this is an index of 2 on the square root. And this is 6 to the first power. So we need to ask the question, if you have 1 power of 6, how many powers of 6 do we need to multiply by in order to get to 6 squared? So this is kind of a silly question. But what we're missing is 1 power of 6, because 6 to the first times 6 to the first is 6 to the second. And that's what we're after. If we have a square root, and a square root has an index of 2, we need a perfect square in order to have an inverse effect on that radical. But remember, we're going to rename this fraction. Not change the value, simply rename. And when we rename, we're going to multiply by the multiplicative identity, which of course is equal to 1. So we are going to multiply by the square root of 6 over the square root of 6. Remember, this fraction is the identity. That's what it represents because it's equal to 1. So when I multiply straight across, I get 15 square root 6, and on the bottom I get the square root of 6 times the square root of 6, which is 6, because they're inverses. If you don't believe me, here goes. If I take the square root of 6 and I multiply it by the square root of 6, I get 6. They're inverse operations. Squaring a square root undoes the square root. So I get a 6 to come out. But don't stop there. Let's be certain to simplify our fraction here. I'll move down and slightly to the right. 6 and 15 have a common factor of 3. This is 3 times 2. This is 3 times 5. Cancel those 3's. We end up with 5 root 6 over 2 for the simplified answer. So 15 over root 6 simplifies to 5 root 6 over 2. All right, let's keep going. So, also from a previous video, a radical sign is a grouping symbol. So if we are able to reduce a fraction underneath the radical, then we should do that. 20 is 4 times 5, and 12 is 4 times 3. So we can cancel those 4's, and we end up with 5a squared over 3b. And if we simplify the radical first, it makes the rest of the problem a little bit simpler. Now what I'm going to do is handy-dandy extendo that radical sign, and we'll do that a few more times this year. And you could multiply by another radical over a radical, or you could just multiply all underneath that radical to begin with. But still renaming the fraction by multiplying by the identity. So we're going to ask the question again. We've got 3 to the first and b to the first. I need a perfect square in order to undo the square root. So I need 1 more power of 3 and 1 more power of b. So on the top, I'm going to have 5a squared times 3 times b. So 5 times 3 is 15, a squared b. We'll deal with the a momentarily. On the bottom, we have the square root of 3b times 3b. 3b times 3b is the square root of 9b squared. Now, let's simplify those radicals. So on the top, the only thing that we can really simplify with an index of 2 is that power of a right there, because nothing's coming out of 15. So 15 is staying, but 2 goes into 2 one whole time. Also, the b is staying. So underneath the radical is 15b, a root 15b. On the bottom, what's coming out? Well, the square root of 9 is 3, and 2 goes into 2 one time. We have rationalized the denominator. Remember, if we rationalize our denominator, no more radicals in the denominator, and that's a best habit for algebra. Now, we always need to consider the index of the radical first when rationalizing. So we just did 2 square roots. Now we're going to deal with a cube root. The index is 3 in this situation. And think about what we have here. And I hope you're thinking that 9, if we were to factor it, would be 3 squared, because that's what I'm hoping that you're thinking. So, can we simplify the cube root of 3 squared? No, because 3 won't go into 2 and 3 won't go into 1, so the a is stuck as well. So if we're going to rationalize this denominator, we need some more powers of 3. We also need some more powers of a. So what do we need? And remember, write that index in, because it's not a square root, it is a cube root. Index of 3. Be certain that we keep the 3 in the spot for the index. So we have 2 powers of 3. If we need 3 powers of 3, we need 1 more power of 3. We have 1 power of a, but we need 3. Therefore, we're missing 2 powers of a. And once again, I will remind you that this fraction, which is equivalent to 1, is the multiplicative identity. We're renaming our fraction in order to rationalize the denominator. So now in the numerator, we have 3 times the radical, so that's just 3 cube root, 3a squared, over in the denominator, we have 3 squared times 3 to the first, which is 3 to the third. No need to multiply it out. A to the first times a squared is a to the third, which now will allow us to rationalize the denominator. Numerator, not changing. 3 cube root 3a squared. Denominator. 3 goes into 3. Remember, we're only comparing powers, exponents here. Index into the exponent. 3 goes into 3 one whole time. 3 comes out. 3 goes into 3 one whole time. A comes out. Last step, 3 over 3 is equal to 1. They cancel. Simplified answer here, cube root 3a squared over a. There we go. That is that one. Last 2 examples here. What if your denominator is an irrational binomial? Prefix bi. Prefix bi means 2 terms. 2 terms in this polynomial. So, if we only multiply by a radical, will it be enough? So, let's do a little error analysis here for just a moment, and we'll just work with number 1. What if I'm like, oh, this is the square root of 2. I must just need the square root of 2 over the square root of 2. Let's see what happens if we do this. So first of all, in the numerator, 3 times root 2 is 3 root 2. And then in the denominator, this is a binomial. If I'm going to just multiply by root 2, I need to use the distributive property. So root 2 times 1 is root 2. Root 2 times negative root 2 is 2. Did that strategy alleviate the radical in the denominator? No, it did not. So if we have a binomial, which has two terms, multiplying by a single radical over itself, not going to be enough. We need to multiply by the conjugate. C-O-N-J-U-G-A-T-E. Conjugate. What is the conjugate? Well, if the denominator is 1 minus root 2, the conjugate of the denominator is 1 plus root 2. Whatever you do on the bottom, we also do on the top, because this is the identity, it's equal to 1. So we still need to distribute. So the 3 is going to get distributed on the top, which will be 3 plus 3 root 2. And then on the bottom, we need to do a double distribution. So distribute the 1. 1 times 1 is 1. 1 times root 2 is positive root 2. Then we will distribute the second term, negative root 2. So that's negative root 2. And then negative root 2 times 2 is negative 2. Hopefully you knew that those middle terms were going to cancel in a conjugate situation. So to the bottom here, we end up with 3 plus 3 root 2 over 1 minus 2 is negative 1. That's a lovely answer. We could just use that negative 1 as the common denominator and change the whole thing to be negative. So negative 3 minus 3 root 2. Okay, very quickly, I'm going to power through this second one. The conjugate of the denominator is 7 minus root 3. 7 minus root 3. So we've got to do a double distribution on the top and on the bottom. Here goes. 5 times 7 is 35, minus 5 root 3, minus 7 root 3, plus negative root 3 times negative root 3 is positive 3. To the bottom, 49 minus 7 root 3 plus 7 root 3 minus 3. Let's combine the like terms. 35 plus 3 is 38. Negative 5 root 3 minus 7 root 3 is negative 12 root 3, because we can only combine like terms with addition. Those cancel. 49 minus 3 is 46. So close. We can simplify this only because 38, 12, and 46 are all even numbers. Let's divide them by 2. 19 minus 6 root 3 over 23. Best, most simplified answer. So last thing, one more time. What if your denominator is a binomial? You'll need to multiply by the conjugate.